This video is about a technique used to solve quadratics known as completing the square. So we've got three objectives here. Number one, can we solve quadratics by square roots? So we have to make sure that we understand how to solve by square roots in order to do this technique called completing the square. Second thing we're going to do is apply the technique for creating a binomial squared, or in other words, let's learn how to do this skill called complete the square. Okay, and then we're going to take that completing the square and then use it in order to solve a quadratic. Okay, so first thing, how do we solve quadratics using square roots? All right, first off, we only want to focus on using this technique when the quadratic has a b value of 0 or it has no b. When it has a b value of 0, we're going to isolate the x squared. We're going to square root both sides of the equation, representing the number as both a plus and a minus, a positive and a negative. And then we're going to solve for the variable if it's necessary. All right, so let's take a look at this first equation right here. I've got 3x squared equals 75. If I were to write this as 3x squared minus 75 equals 0, you see that it has no b value. That's what's telling me square roots is a good option here. Now, the first step of square roots is to get just the x squared by itself. So in this case, I've got a 3 there. So I got to divide both sides by 3, and I'm going to rewrite this as x squared is equal to 25. Okay, now it's set up to use square roots. I'm going to take the square root of both sides, and that leaves me with x is equal to the square root of 25. But because I'm using square roots to solve, and I know that a quadratic should produce two results, I'm going to show both positive and negative representation. So yes, I should get two answers here. Now another way, and I'm going to use this way more often throughout the rest of the lesson, another way to write that is to say plus or minus 5. Okay, they mean the same thing. So let's look at the second equation. Okay, I notice there's no b. Immediately I say I want to solve by square roots. So the first thing I'm going to do here is I'm going to add 49. So 4x squared equals 49. And then I still don't have this x squared piece by itself. I'm going to divide both sides by 4. And I get x squared is equal to 49 over 4. Now, even though 49 over 4 is not a clean division, okay, yeah, I could get a decimal for it. But I want to focus on using this technique called square roots. All right, when I take the square root of x squared, I get x. When I take the square root of 49, first thing I always like to do is write plus or minus. Just get it out of the way so you don't forget about it. Then I worry about simplifying the numeric square root. Square root of 49 is 7. Square root of 4 is 2. So I get plus or minus 7 over 2. All right. Keep in mind again, what are these x's that we're finding? They are the x-intercepts of the quadratic. All right, how about one like this next one? 2x squared equals 14. Again, divide to isolate the x squared. So I get x squared is equal to 7. Use square roots to get the x all by itself. Write down plus or minus so you don't forget. But what if I get a square root that I can't simplify? That's okay. That is still an actual location on the x-axis. So I get plus or minus the square root of 7. Now, this one gets a little bit different. If you notice here, we have a binomial that is being squared. The whole squared piece is the x minus 3. So in this particular case, I do already have the squared piece isolated. So what's my next step here? I'm going to take square root of both sides. When I take the square root, I'm going to get x minus 3. So just the symbols cancel each other, the square root and the squared. And on the right side, I have a plus and minus, or positive and negative, 4. This is still not solved for the variable. All right, so what do I need to do here? I'm going to add 3 to both sides. That leaves me with 3 plus 4 and 3 minus 4. I clean that up and I get x is equal to 7 and negative 1. Again, why did this technique work? Because we didn't have a b value, like in the previous one where we didn't have a b value. We would have had a b value here, but we had a binomial squared. Now, that's going to be real important down further in the lesson. Okay, so let's move on to the second objective. Second objective is, can you complete the square? All right, all that completing the square is rewriting an expression in a perfect trinomial that becomes a perfect square binomial. Okay, so what we're going to do, here's the technique. We're going to rewrite the quadratic in the form x squared plus bx plus blank. This is critical right here. Notice, in order for this technique to work, a has to be equal to 1. We're going to divide b by 2. We're going to square it, and we're going to add it to the blank. That right there is the majority of the work in completing the square. And then what we're going to do is we're going to write the trinomial in factored form. All right, so let's try this here. I have a 1 for my a, so I'm okay. I need to fill in this blank right here. So what I'm going to do is take b, 22, divided by 2, get 11, and square it. That squared value goes right here. This now completes the square, but we want to take it one step further. I want to take this trinomial and write it as a binomial squared. So this would be x plus 11 squared. This is how I want to finish completing the square. Now let's figure out where everything came from. So we took b divided by 2 and squared it. That's completing the square. I filled that in. I know that x came from x squared. I know that the 11 really came from what value I squared to get the 121. Now, both the 121 and being able to write this binomial squared are important. You're going to see that in a little bit. All right, let's try a couple more though. What if I've got one like x squared plus 5x plus blank, where 5's odd? All right, it's not going to work out as nicely. I can still do completing the square. I take 5 divided by 2 and square it. That 5 divided by 2 squared leaves me with 25 over 4. I know that 25 over 4 completes the square. Therefore, I can write it as a factored form, x plus 5 over 2 quantity squared. Okay? What if we get one where we don't have an a value of 1? Well, now we got to play around with this a little bit. All right, first thing is I can't complete the square unless a is 1. So what am I going to do? I'm going to divide everybody by 4. That leaves me with x squared minus 3x plus blank. All right, so let's think here though. If I divide it by 4 when I complete the square, am I going to need to put that back in? I don't know. We'll have to see. All right, so let's take b, negative 3, divided by 2, square it. Okay, so if I do that, I have 9 over 4. Okay, and if I were to plug 9 over 4 into that original, and then I cancel back those, let's see, would that give me the right answer there? Yep, this would work. So what's completing the square down here is actually just going to be this value on top. So I'm going to worry though about rewriting this one, and this is x minus 3 over 2 quantity squared. All right. One of the reasons why I don't recommend completing the square when you have an a value other than 1 is things tend to get confusing. If you notice, I did a whole little side note there where I didn't really talk about what I was doing. I was thinking my way through it to determine whether or not it worked. Okay? So just kind of giving you guys a heads up on what I'm doing there. So let's finish this lesson up by now taking what we've learned, square root technique, and taking this concept of completing the square and trying to put it all together into a problem. So to solve a quadratic by the technique called completing the square, the first thing we want to do is complete the square. So I'm going to write the quadratic as x squared plus bx plus blank. But notice I'm going to take the c and move it to the other side and put a second plus blank. I call this the setup. First thing you got to do is get your quadratic set up. Okay? Again, note a is 1. That allows me to complete the square. I'm going to complete the square, but then I'm going to add the value that I was adding in the blanks. I'm going to add it to both sides of the equation. Right, the left side is a perfect square. We're going to square root both sides, remember, in positive and negative representation, and then solve for the variable. Now, if I recognize, like on this first one, if I recognize that the left side is already a perfect trinomial, I can factor it. So that's the whole reason why I wrote this problem in here first. I look at this and say, wait a minute, I know this is x plus 3 quantity squared equals 1. Now I don't have to use completing the square technique. All that I need to use is square roots to solve it. Why? Because I wrote a perfect square binomial. So then how would I solve this? Square root both sides. And that leaves me with x plus 3 is equal to plus or minus 1. Or x is equal to negative 3 plus or minus 1. Which means x is equal to negative 3 plus 1, or negative 2, negative 3 minus 1, or negative 4. Okay, now what about one like this one right here? On this one, x squared plus 10x minus 1. There is no way that I can do that one as a perfect binomial squared. So this one, I need to use a technique. I'm probably going to need to move some of these other problems down a little bit, but let's go for it. Here we go. So I'm going to rewrite it as x squared plus 10x plus blank equals, I'm going to take that minus 1, move it to the other side. 1 plus blank. I call this step the setup. Now, I'm going to take b, which is 10, divided by 2, 5, and square it. That leaves me with 25 and 25. Okay, I'm going to rewrite the left side as x plus 5 quantity squared, and 1 plus 25 on the other side is 26. I'm going to square root both sides. That leaves me with x plus 5 is equal to plus or minus square root of 26. 26 doesn't have any perfect square factors, so I'm going to leave it as square root of 26. And then if I solve for x, I get negative 5 plus or minus square root of 26. That is the exact locations. Remember, negative 5 plus the square root of 26, negative 5 minus the square root of 26. Those are the exact locations where this quadratic would go through the x-axis. Okay? All right, let's try a couple more of these. I'm going to move this bottom one down a little bit just so I've got more room. Okay. All right. If I try to move everything over, in other words, set it equal to 0, I get x squared plus 2x minus 11 equals 0. Okay. That's my first thing that I want to do to solve this quadratic because I'm hopeful I can factor it. But as I look at it, I can't factor it. So then what's my next course of action? I'm going to complete the square. So I'm going to set it up. X squared plus 2x plus blank equals 11 plus blank. All right, to complete the square, take b divided by 2, which would be 1, and square it. 1 squared is 1. Now, sometimes I might write it like this. 1 squared over on this side and then write 1 on the other side. Okay? I'll show you why I like to do that. Because now when I go to factor this, I know this is x plus 1 quantity squared. In other words, I use this x and I use this 1 to help remind me what the binomial pieces are. On the right side, I get 12. I now can use square roots. So that leaves me with x plus 1 equals plus or minus the square root of 12. Now I know the square root of 12 can be simplified. Its factors are 4 and 3, so that leaves me with 2 square root of 3. I'm going to solve for x by subtracting 1. I get negative 1 plus or minus 2 radical 3. This is the exact. Now, a couple of you guys I know have said, well, I can find the answers as decimals. These are the exact answers. All right, a calculator can find them as decimals. We have to be able to find both exact and decimal approximations. We're going to wrap up all of our quadratic stuff by showing you how to do that later. Okay, I come over to this next one. Now, this next one, I notice right away there's an a value of 25. I don't want to do this by completing this square. All right? I can, but I don't want to. It's going to be too messy. The one thing that's intriguing me, though, is over on the right side, I see a 9. So I'm going to look at this quadratic once again. And one of the things that I notice is this is a perfect square. I know the goal number is 25. The middle term is 10. That means the factors are 5 and 5. They're the same. All right, so what I have to do, though, is figure out what is the factored form of this. All right, in short, I know this factors to 5x plus 1 quantity squared. If I can write a given trinomial as a binomial squared, I want to do that. If I don't recognize it, then move on to another technique. Okay, square root both sides. That leaves me with 5x plus 1 is equal to plus or minus 3. I'm going to subtract 1, so 5x is equal to negative 1 plus 3 and negative 1 minus 3. I just separated the plus and the minus because I'm seeing a bunch of numbers. So now I have to divide each of them by 5. So negative 1 plus 3 divided by 5, and negative 1 minus 3 divided by 5. And then I'll clean that up. Negative 1 plus 3 is 2 over 5. And negative 1 minus 3 is negative 4 over 5. And again, those are the two locations it crosses through the x-axis. All right, let's try one more. What if they insist that I use completing the square? Okay, we can do that. If they insist that I complete the square, the first thing I know is I cannot complete the square unless a is 1. So I'm going to divide everybody by 4. Okay, this leaves me with x squared plus 5x plus 1/4 equals 0. Okay. I'm not a fan of this technique, but I'll show you it can be done. All right. I need to now get it set up to complete the square. X squared plus 5x plus blank equals negative 1/4 plus blank. I move that c to the other side. I'm going to take b divided by 2, so 5 over 2 squared. That would give me 25 over 4. I'm going to rewrite the left side as x plus 5 over 2 squared. I'm going to rewrite the right side as 24 over 4. I'm going to square root both sides. That leaves me with x plus 5 over 2 equals plus or minus, let's see, the square root of 24, which would be 2 radical 6 over the square root of 4, which is 2. Okay? Now, I could clean that up to just leave it as the square root of 6. So I'm going to rewrite this as negative 5 over 2 plus or minus square root of 6. Yes, I could have simplified 24 over 4 up ahead as well. All right. If they want this written as a fraction, so this is the correct answer. If they want this written in a fraction form, the answer would be negative 5 plus or minus 2 radical 6 over 2. And I cannot cancel those 2's. We'll talk more about that in the next lesson. Hope this helps. Good luck.